semantically distinct and the syntactically distinct hypothesis, right?
Yes.
So at one calculation I mentioned wrong. Wow, I understood it wrong. 1 second. Okay. So distinct instance, it will be based on the possible option.
Yes.
Each attribute, how many possible options are there? When we multiply it, we will get the distinct instance.
Yes.
And comes to syntactically distinct hypothesis, we are adding in each case the null and
question mark.
So then it will become this. The third case, this case, what is happening is, if any of these instance has a null value, any of these attributes has a null value, that we cannot consider. For example, sky, air temperature, like that, 6 attribute, air temperature, humidity, wind, water, forecast. So any of these has a null value, it is considered as null. So what in that case, that means instead of adding 1 in each entry, that one with null they are taking out. We will not make this from all these entry. We are just taking that null out and making it as 1 plus, and 1 without null is 4 into 3 into. So it will be just the first one, number of possible options plus question mark only we are adding and multiplying, plus 1 for all the null entries.
Okay.
To make it more correct, because if null comes in, so what they are telling is, however, that every hypothesis contains one or more null symbols represents that the empty set of instance. So any one null set comes in, right, that entire set is a negative instance. So it classifies every instance as a negative. Therefore, in order to avoid that, they are taking that one. Means any instance has a null value, it will be considered only once, and rest of it is calculating. So
okay, so I got this, that they are considering only single null value, okay, for all the in all the places, because they are considering as an empty value, isn't it?
Correct.
But I don't get the why they are doing this. It means that where it is impacting it.
So any one null comes in, right, that is a negative instance. So
negative instance.
We don't have to keep, because null means it doesn't satisfy that requirement, right? Any value is question mark, and null value is no value.
No value.
So any missing value, when it comes, usually we will not consider that entry, or we will just do a hard-coded value, means we will consider it as unknown value. So all these unknowns, we can take it as just one single instance.
Okay, fine. So you are saying that suppose we started with 6 nulls, okay, and there are some instances again, okay, like sunny, high, cold, like this, okay. And in those instances in future, suppose instance 1, 2, or 3, we got null, then we will ignore that value. You are saying like this.
Correct. Any missing value, in this case we are considering, means all the missing values we are together taking it. Hello? Am I audible?
Yeah, Veena.
Hello.
Yeah, you are audible. I think some issue with the connection. So just to refresh, on the finders algorithm, we first took the specific hypothesis with all the null conditions. Then we arrived at a single hypothesis. So we are considering each sample value, and finally we arrived at a single hypothesis. Till here we have covered yesterday, right?
Hello, Veena, are you back?
Yeah, I am able to hear you.
Hello. Screen is not screen.
I just dropped it. Aman was asking, right?
Okay. Yeah, because we can see your skin.
Okay.
Now you have removed the skin.
Yeah, I will reshare. Any questions on
Yeah.
find algorithm?
No, Veena. So in last, yesterday session, don't have any question. But today, what you were telling now about the null, that I didn't understand that how we are going to use it. Like,
Okay, this one plus you are asking?
yes. I'm still having doubt in this.
See whether I can get a pen here. So we have these cases, right? One is sky. The other one is air temperature. Let's consider two cases.
Okay.
So for sky, we have three values: cloudy, sunny, and rainy. And air temperature, we have two values: normal and I don't know, high. I will just put values. So here, for the total number of instances, what we are doing is we will take how many possible values are here and how many here, and we will multiply. So it will be 3 into 2.
3 into 2, yes.
So that we will get. The second case is syntactically, no, let me see.
Yeah, syntactically distinct.
Yeah, syntactically distinct one. So in that, right, when we write the hypothesis, this is instance. Here we are considering the instance. Give me a second. Sorry about that. So these are the 6 instances. Now we are considering how many hypotheses we can write with this. So we can write cloudy normal, sunny normal, rainy normal, cloudy high, sunny high, rainy high. 6 we can write. In addition, we can write anything with anything, right? If we have sky is question mark and air temperature is question mark, also we can write. Or sky is question mark, air temperature normal. Like that we can write. We can have one more entry question mark here. And the other entry is null.
Null.
That also we can write. So total number here is 5 here and 4 here. 5 into 4 it will come 20. That will be the number of distinct hypothesis.
Yes, synthetically distinct hypothesis.
That is 5 into 4. Now, when this case comes in, right, null into normal is also a null. Null into high is also a null. Similarly, sunny into null, anything into null, right, it will be considered as a null entry or negative entry. Similarly, null into null is also a negative entry. Rather than considering it so many times, we are taking that one entry, null, as outside. Then we are taking the rest of the instances. So it will become 4 into 3. this one we will add 4 into 3, 12, 12 plus 1, 13. That will be the semantically distinct hypothesis.
Okay.
So this will be for all the cases, it will be the same. So if we are getting all the possible values, we can consider that. If we are not getting all the possible values, we need to take it from the training example which they have given.
So they are doing this because it is not possible that it does not have any value. That's why they are taking it as negative or something like this.
No, they are considering, means even if we consider it right, with them it is same. Means whenever we have a missing value in our data set, usually we will either default it to unknown or we will make it as a outlier or missing value. We will remove that missing values, right?
Okay.
So it is similar. Anyway, it is an unknown one. We will not be able to find it. So we are just considering it as one. So this you can read through. They are telling there are some disadvantage with the finders algorithm. Finders algorithm will only give the one hypothesis, right? Finally, we are getting only one hypothesis. That may not be the case always. It will give the most specific hypothesis, but there can be other hypotheses also for that. Or there can be other cases also which satisfies the target function. We are finding one specific case or one case which is the most specific one. Other cases also there are. Basic. So those are some cases where finders algorithm will not work.
Okay.
So in that case, we have one more algorithm, which is candidate elimination algorithm. For this, the way we are calculating, let me see. So here we are listing all the elements of the version space.
Version space is H1, H2, up to Hn. All intermediate hypotheses.
So version space is the space where all the hypotheses fit in. So we are trying to identify that version space through this candidate elimination algorithm. So for that, okay, let me take that example. let me see, I can explain with this or not. So what we are doing is we have this specific case, right? The most specific cases with all null and most generic cases with all these question marks. Then we will take each instance, and each instance we will validate it against the generic and specific cases. So when we check this one, okay, the first one, when we check for the specific case, right? Specific is all null. It doesn't match with this instance. If you take sunny, warm, normal, it is not matching with null. Just take the specific case. So specific case, none of this will match. So we have to replace the specific case with this one. So we have the instance. X1 is the instance. Instance has sunny, warm, normal, strong, warm, same. And we will match each attribute with the specific case attribute. So null is not equivalent to sunny. So we will replace sunny. Same way, null is not equivalent to warm. We will replace warm. Like that, each attribute we will replace. Each value we will replace and create a new specific hypothesis. Same way, we will compare it with generic hypothesis. Warm, sunny equals question mark. That is true only, right? Question mark can take any value irrespective of what value it is. So the generic hypothesis will stay the same. Specific hypothesis will change. So this ignore that Hindu mark, but we are creating. The first we will start with a specific and generic. Specific is all null and generic is all question mark. Then we take the first instance, compare each value of the instance with specific case first. So none of it is matching, so we will replace it. Now we are comparing it against the generic case.
Veena, one thing. X1 equal to whenever you are comparing with the sample space all null and your specific, this is general is all the question. So you are replacing just whatever the actual instance is there, that only doing. Plus, what is that plus? That finally, after this, now all the instance after the at the end plus is there.
Now that is
X1 equal to
representation they have given. It's a positive case. That case means finally we are converting it into a Boolean value, right? Target function is a Boolean one. Target concept we have learned it is a Boolean one. So this is a positive case. Enjoy sport is yes. Then it is a positive case, right? If you remember, let me go back to that. This case, the first case we are taking. First is a positive case, second is a positive case, third is a negative case, fourth is a positive case.
Okay. Yes.
We are taking the same example which we have seen in the finder's algorithm for the candidate elimination also. So first case when we take, what we are doing is in the finder's algorithm we are taking a specific case and then arriving at the algorithm, the most specific algorithm. But here what we are doing is we are considering both specific and generic, and we are comparing each instance value with each attribute of the specific and generic. And if it matches, we will take it. If it doesn't matches, we will replace. So this case, the first case, you are clear, right?
Yeah.
So the first case we are taking, it is a positive case. It's just a representation. So we are taking this case and validating. So the specific is not matching. So we are replacing each value of specific with the instance value. Whereas generic, it says any matches with this value. So we are keeping the same. Now we are taking the second instance. Second instance is also a positive instance. Here also we are comparing. When we compare sunny, then at that time we are comparing the specific case which we created here. So here sunny is matching with sunny, warm is matching with warm, normal is not matching with high. That's where we are replacing normal to question mark. The third one has two values now, either normal or high. So any value we are keeping here. Next three are strong, strong, warm, warm, same, same. It remains the same. And when we consider it, compare it with the generic one, all the values, it's again any, right? It matches exactly. We don't have to replace it. Specific changed, generic remain the same.
But similar we do in this find as now.
Find as we are taking only specific and following. Here we are comparing against both specific and generic. In the find as we will arrive at one hypothesis. Here we will arrive at a set of hypotheses. That's the difference. We will see that.
But I see the process is the same in the both cases. No?
Correct. Process is same. Okay. The below one is not there. There, the generic case we are not comparing. Only from specific we are arriving at the hypothesis, right?
Yeah.
So here we are comparing each time at the generic also. So going to the next case. So here this is the same. So now we take the third case. Third case is rainy, cold, high, strong, warm, change. This is a negative case. It is not matching with what we have. But in the finders, we used to ignore the negative case. Here we still consider the negative case. But when we take the negative case, the specific will remain the same. But the generic case we are changing here. So it is this case, the rainy is, this is a negative case. So rainy, we don't have that. We don't have in the previous two cases. So that case we are writing sunny and rainy. So rainy is a negative scenario. So we are not considering rainy. We are not changing that. We are telling sunny or rainy is a generic hypothesis. The reason is we are comparing each attribute with the specific case, generic case and taking, right? So here we are forming multiple sets. So the case where rainy and sunny is not matching, so we are telling when it is sunny and rainy, that is a generic hypothesis. Similarly, we are comparing next one, warm against cold. Cold is a negative case, warm is a positive case. So we are telling warm and rainy is a generic hypothesis. Previously, we were telling in any is a generic hypothesis. Now we are defining it more. That generic category of any we are changing to more specific one. So that's where we are telling warm and any also can be considered as a generic hypothesis. Third case we are taking is high and question mark. High and question mark anyway it matches, so we don't have to compare it. And strong is strong. Strong is the third case also is strong, right? So we don't have to compare. Warm is warm. Same and change. There also there is a change here. First case is change. Our hypothesis was question mark. For the negative case, we are telling. So the specific will remain the same. The generic we are changing. The generic cases we are framing. So we are checking what till now what was the case. All sunny. Then the rainy is a negative case. So we are removing negative. Similarly, all warm. Cold is a negative case. We are removing cold. Third case, till now all was change. Sorry, all was same. And now change is a case. So we are putting for that 3 generic cases we are framing.
Veena, can you take a small example and can explain?
Yeah.
So I'm not getting fully.
So coming back to this same case. So instance 1. Let me put some newly. So we will first start with the null hypothesis. So null hypothesis, it will check for the first instance x1. It will become this is not same as null, right? So then we will replace this. This is for the specific case, and for the generic case, what we will do, we will check. We have question mark here. So question mark stands for any. When it compare with these two, it is any. So we don't have to change anything here. So this will remain the same for the instance 1. One step down. Now we will check for the instance 2. Instance 2, this is Sunny. So Sunny will remain the same. And here it is normal. And we got high. So consider these two as positive cases and negative case. So here it is normal. So we have to change it, right? So only item which will categorize to both normal and high is question mark. So we need to replace it with question mark. So this is our new specific hypothesis. And both will categorize. Now we are comparing it against the generic one. Sunny will be same as question mark. High will be same as question mark. So we can just keep the same generic hypothesis. Now we are checking for the third case. Third case is a negative case. Negative case means rainy is a negative criteria. Rainy hasn't come in the previous positive cases. So this entry, we know it. This is not a question mark. This is a negative criteria. So we will keep, when it is a negative criteria, we will keep the specific as is. We will only change the generic. Generic, how we will change is this question mark. Rainy is a negative one. So we will not consider negative. We will consider only Sunny. And we will tell this is question mark. Because this has both value, right? So we will keep. So this is our new generic hypothesis. And this is our new specific hypothesis. So we have only, means in this scenario with this entries, we have only one hypothesis. We are arriving both generic and specific is converging. We got same generic hypothesis and same specific hypothesis. Now consider a case where adding one more. So in this case, we will consider the same Y criteria. This is the concept.
Veena, one question. How we reached same generic and specific hypothesis, both are same, from this left side, whatever the instance you have made? No? From
we
that,
are,
how you reached?
let me go back to that hypothesis.
Okay. Okay, from here.
Okay. So here what we are telling is we will list in the version space a list containing every hypothesis in H. For each training example XCX, remove from version space any hypothesis H which is not equal to CX. Output the list of hypotheses. So that elimination process we are doing. We are first listing all the hypotheses and then eliminating it. So the very first hypothesis we eliminated is the null hypothesis here. If you, in this example, sorry, I'm going back and forth. In this example, we have first eliminated, we have this null hypothesis and generic hypothesis. We eliminated this null hypothesis first. Because our first instance is sunny or normal. When we validated sunny against null, it is not matching. Normal against null, it is not matching. So we just replaced it with the current instance value. This you are understanding, right? Null not equal to this attribute value and question mark equal to attribute value. Okay. Instead of null, I will say no value. No value, it is telling it doesn't have any value. Then it cannot be equated to sunny, right? And question is any value. So any value means anything comes in, whether it is sunny or rainy, anything it can take.
Yes.
So if it comes sunny, we are taking we are considering the same one. Whereas it is telling no value and it is coming sunny, we will take the current instance value.
Current instance always.
So we replaced it with sunny and normal. Now we consider the second instance. Second instance, sunny is repeating, so we don't have to change it here. And when second one, when we compare high with normal, it is not matching. So we have two values now, normal and high. So to replace that, we have only one value, any value. That's where we are putting it question mark. Again, same thing we are comparing here. This is also a positive case, right? So any value means it is positive. We are taking both. Third case it comes in, it is a negative case. Whenever negative scenario comes in, then only the generic is changing. So negative scenario, rainy is coming in. So we are telling rainy is a negative case. We don't have to consider it. So sunny is the most generic value.
Generic. Yes. Okay.
We are changing this to sunny and question mark. Because here it is not changing. High is already there in the...
No, you are telling sunny is the most generic value because in case of sunny, it is showing YY. That's it.
That's correct. That's correct.
Yes.
That's correct. So that is the value, which means till now that is the only value for the sky.
Yeah, I cannot hear you. Can you repeat? Maybe my network issue is there. See, what I am telling that because of sunny in first two row, it is telling yes. So that's why it is the most general you are telling.
That's correct.
Okay.
So now we have this case. Here we are writing the specific and generic. So in this case, the specific will be
sunny only.
same. Sunny, normal, high, it will come.
First case.
And here it will be all question mark. This is the specific one. Sorry, generic one. Now second case we are taking Sunny, we are comparing against Sunny. That is matching. So it will continue. High we are comparing against normal. That will not match. High we are comparing against high. That will match. So Sunny and high will continue. And normal we will replace with question mark. And this case will again continue only, right? Because that's the only generic case. And third case when we take Sunny, we are comparing against rainy. That is a negative case. So when it comes a negative case, right, we will take the same specific here. Specific we will not validate. Only for the generic we need to validate. So generic when we validate, we need to prepare the hypothesis. Rainy is a negative case. And we are telling till now we have got Sunny only. So the first hypothesis we will be framing is, here we have multiple hypotheses. Sunny, any, we are telling. This is one generic hypothesis we are telling. The second case is, we are taking high. High we are not able to compare. So we will ignore it. Because high is yes, high is a no also. So we will just ignore that case. The third case is high, low. So low is a negative case. We have only high. So we are framing another generic hypothesis like this. So one is Sunny, question mark, and second hypothesis is question mark, high. So now we have three hypotheses. One is this specific hypothesis and two generic hypotheses. And this together comes in the version space. With that example, consider the same case. The first case, we are taking a specific case which is all null. Generic case, all question mark. Consider the first instance x1, which is a positive case which has value all these warm, sunny, warm, normal. We compare it with specific and replace each entry with the instance value. That will be our next specific case. And generic will remain the same for all positive cases. So we are just putting the same generic. The second case we are taking, that is also a positive case. We compare sunny against sunny, warm against warm, high against normal. This is not matching. So for high and normal, we have only one value to replace. That is question mark we will replace. The rest are same. We will keep the same. Strong, warm, same. For x2 also it is strong, warm, same. We will keep the same. That is the second specific hypothesis we are framing. And for that also, since it is a positive case, generic will remain the same.
Veena, can you go back to that sheet once more? Just for us. No, that sheet, the Excel sheet, where you were explaining. Yes. Okay. So if there is an option, sunny, rainy, and cloudy, okay, then what will be the generic case here?
You are telling cloudy will come in the first entry?
Yeah, cloudy. There is one more option of cloud.
Then this will become question mark here, right? In the specific scenario, if we have this cloudy, I'm keeping high. And export. So in this case, when it is a positive case, specific will change. So now we have sunny and cloudy. This will become question mark.
Question mark, yes.
And this will be question mark. This will be high. We will see a similar case in the other one also. So I think that's fourth case. So third case, okay, sorry. It's a rainy, cold, height. This is a negative case. So we are framing this cases. So we are comparing rainy against sunny, which is a negative one. So we are just considering sunny and question mark. Rainy against cold against warm. Cold is a negative case. Warm and all question mark. We are not considering these three because question mark is can have any value. Strong is strong again. In the instance 3 also strong. Warm is warm. So the last case is same. So till now specific case is same and in the negative case change came in. So we don't know change is a positive or negative one, right? Based on the current data, change is a negative scenario. That's where we are putting it as same. So we framed this query. But when we got the last instance, sunny remains the same, warm remains the same. But when we check for this change, right? Change is a positive case here. But we are telling same is the positive one till now. So we are removing that generic hypothesis. So when we have multiple values, then we cannot keep this hypothesis as is, right? The same thing will happen in the other Excel entry also. So we will remove this case and we will tell this is the generic hypothesis. Similarly, in our case, the other two values, when we compare warm against cold, both are positive. Till now, warm was positive. Now we are telling cool is also positive. So we are replacing with question mark. And we are telling till now same was positive. Now we are telling change is also a positive one. We are replacing it with question mark. So this will be our final work. We have three options, right? These three will come as the version space.
Okay.
I know this is little confusing, but once you write it and do right, you will understand.
So here we create version space, and in the finders we come to a specific hypothesis.
Correct. This also has some issues. Whatever we are arriving here, right? That is also not the most generic one.
Okay.
That you will see. More detailed description that those entries, right? How we are framing, that is here. Yeah, just go through these remarks. So this will tell what are the issues with the candidate elimination.
Okay.
So what we are telling is whatever hypothesis we are framing, right? That may not fit in the proper version space. So some of the entries might be outside the version space which we are defining. So in that case, whatever hypothesis we have derived is a biased one. So that version space, whatever we have derived is a biased one. So that's what they have defined here. You can just go through it. Maybe in the next class we can cover it. I will send you some links also where some problems are there on the candidate elimination.
Yeah, that will be better.
That will be helpful actually. You just shared those things.
Yeah.
And this PDF also along with that you share, no?
This one is the textbook only.
Textbook.
Actually, what we are doing is we are following this textbook.
Okay. Yeah.
Anything else?
Okay, we just share those material with just sample example so that we can get an idea that yes, from this kind of similar problem comes, how can go ahead the steps by step.
Yeah, sure. We can take one session on Saturday. Tomorrow I will not be available. Saturday.
Okay, fine.
Hmm.
So,
And
instead of Friday, you will take it on Saturday. Huh?
That's correct.
yeah. And as of now, whatever they have taken the session class, those PPT, if you can once again can just go through and explain, no, that will help us also.
Yeah.
In the class. That also we wanted to know how much we can grab from that PPT, whatever they have shared, no, in the session class.
In our class, right?
Yes, yes, yes.
Let me quickly share.
Maybe Saturday you can think of it sometimes, no? All the slides, no? This talking about this, so that it will get an idea, yes.
Okay, sure.
You have shared the link regarding this sample example and all.
No, I will share. I will share in that chat group. I can put.